Why is no one willing to admit that Oumuamua is alien technology? Some of its behaviors seem to defy all known physics. Scientists say it's not a comet, not an asteroid, and might not even be naturally formed. So what is it? Why does every explanation feel like it's avoiding a more dangerous truth? On this journey, we won't dive into mysticism, we'll stick to the evidence, seeking the most accurate answer possible. But to truly grasp the shock Oumuamua brought, we need to rewind to the moment it first appeared. On October 19th, 2017, Hawaii's Pan-STARRS-1 telescope spotted it. At first, scientists thought it was just another comet, naming it C2017U1. But strangely, it had no coma and no tail. Days later, it was reclassified as an asteroid, designated A2017U1. Yet as calculations deepened, they discovered this thing was on a hyperbolic trajectory. In other words, it wasn't orbiting the sun, but accelerating away from the solar system entirely. So scientists had to create a whole new category for it. It was officially named Oumuamua, marking the first time in human history we'd ever seen an interstellar visitor. The name comes from Hawaiian, meaning a messenger from afar. It honors the telescope that found it, while also hinting at its role as a cosmic scout. But from the very first second it appeared, nothing about it made sense. It was too fast, its path too bizarre, nothing like the familiar objects in our solar system. Instead, it seemed like an intruder. It briefly skimmed past the sun, even dipping inside Mercury's orbit, where it hit an astonishing speed of 54 meters per second, before the sun's gravity slingshotted it straight back into interstellar space. Astronomers worldwide scrambled to observe it in the few weeks it was visible. And as it tumbled through space, they noticed something shocking. Its brightness fluctuated wildly, as if it were an extremely elongated, or even flat, object spinning. Early estimates suggested it could be 400 meters long, with a length-to-width ratio of 10:1, like a cosmic cigar drifting through space. But further light curve analysis hinted at another possibility. It might actually resemble a pancake, with proportions between 6:1 and 6.6:1. Whatever its shape, it looked nothing like any known comet or asteroid. It wasn't large, just a few hundred feet wide, with a deep red surface, likely weathered by cosmic radiation over its long journey. But the hardest thing to accept, it had none of the gas or dust typical of comets. Astronomer Karen Meach put it bluntly, even as it passed the sun, our most powerful telescopes detected not a single trace of dust around it. Yet the mystery was just beginning. Its trajectory couldn't be fully explained by gravity. As it moved away from the sun, it showed a faint but clear non-gravitational acceleration, as if something was gently pushing it. Comets usually accelerate from outgassing, but Oumuamua had no detectable gas at all. This left scientists baffled. What kind of object speeds up without a tail or outgassing? Was it releasing some invisible material? Or was it not natural at all? The public quickly speculated, could it be an alien craft disguised as space rock? Most scientists still leaned toward natural explanations, but their theories sounded shaky, even contradictory. One thing was certain, Oumuamua was real, but what was it? Why was it here? No one had a definitive answer. In 2020, two scientists proposed a bold new idea. Darash Seligman and Gregory Lalin suggested, Oumuamua might not be made of rock, metal, ice, or gas, but something far rarer, molecular hydrogen ice. Their theory went like this: in the depths of space, there are regions called giant molecular clouds, where temperatures near absolute zero could birth objects like hydrogen icebergs. When such ice nears the sun, it sublimates, turning directly from solid to gas, without much heat. This sublimation isn't explosive like a comet's jets. It's quiet, even, almost invisible, as if the whole object has tiny, hidden thrusters. Since pure hydrogen is nearly undetectable in visible and infrared light, it wouldn't glow or leave a trail. So visually, it looks like an asteroid, but its motion resembles a disguised comet. This model neatly explained two big mysteries: why no outgassing, and why the acceleration. It even accounted for Oumuamua's odd shape. The scientists argued that hydrogen sublimation would erode the object, stretching it over time, possibly explaining its cigar-like form. They also noted such hydrogen ice bodies could only form in extreme cold, like the cause of dark molecular clouds near 3 Kelvin, just above absolute zero. If Oumuamua came from there, its billion-year journey wouldn't be surprising. But this elegant idea soon faced fierce criticism. Later that year, astronomers Thumholm and Avi Loeb published a rebuttal. They argued hydrogen ice sounded nice but couldn't survive. First, starlight, even the faintest glow in the galaxy, would slowly heat and evaporate a hydrogen iceberg. Their calculations showed an Oumuamua-sized chunk would vanish within 10 million years, but Oumuamua's path suggested it was over 100 million years old. That alone made the hydrogen model shaky. Worse, if Oumuamua really came from a dense cloud core, escaping would mean plowing through gas and dust, speeding up its evaporation. It wouldn't survive the trip. The final nail. Hydrogen ice might not even form. Its particles are so unstable, they'd scatter before merging into an iceberg. The conclusion was harsh. A pure hydrogen object couldn't drift intact across the cosmos. It would have melted long ago, like a snowflake in space. This debate is science at its best, not about who's right, but pushing closer to truth through challenge. And with that, the question returned, if not hydrogen ice, what was Oumuamua? As old theories fell, a new one emerged in 2023. This time, it made scientists nod. Chemist Jennifer Bergner and Darash Seligman teamed up again, proposing a simpler idea. Oumuamua wasn't made of exotic ice, just ordinary frozen water. It was likely a comet-like fragment that transformed during its cosmic journey. Here's their vision. Over millions of years, cosmic rays bombarded its icy body, triggering reactions inside. In labs, we know radiation can break water molecules, trapping hydrogen gas in tiny bubbles within the ice. By the time Oumuamua neared the Sun, it held a hidden reservoir of hydrogen. As it warmed slightly, the ice restructured, releasing trapped gas. A gentle, steady push, explaining its acceleration. This process was invisible. Hydrogen doesn't glow or leave traces. No tail, no dust, just silent thrust. Bergner and Seligman calculated that releasing mere grams of hydrogen per second could match Oumuamua's motion. This theory fit perfectly. Its reddened surface matched long-term weathering. No detected gas. Check. Small size. Check. Non-gravitational acceleration. Explained. Their conclusion. Oumuamua was likely a simple comet fragment, altered by time and space, carrying a hidden hydrogen engine. No aliens, no exotic physics. Just cosmic chemistry, and a reminder, sometimes the most mysterious things are the ones we misunderstand. But one question remains, where did Oumuamua come from? In 2018, astronomers traced its path backward, suggesting it wandered for hundreds of millions of years, possibly ejected by a young star system's chaos. Gas giants like Jupiter often fling small bodies into deep space. Maybe Oumuamua was one. Another theory, it came from a binary star system, where unstable orbits could have launched it outward. Or perhaps it was debris from a collision with a Pluto-like world. Today, Oumuamua is over 40 astronomical units away, 40 times Earth's distance from the Sun, still speeding into the unknown. But next time an interstellar visitor arrives, we might not just watch it pass. We could reach out, study it, even chase it. The question isn't if we'll see another Oumuamua, but when. And each visitor could rewrite our understanding of the cosmos. We don't know where they come from, or what they'll teach us. But one thing's clear, when the next stranger streaks through our sky, we'll be ready. Make sure to hit that subscribe button, give this video a thumbs up, and share it with your friends and family. Thanks a bunch.